So for our warm-up, what's the length of the missing side? How do you find this? How do you find the length of the missing side? Good. This is a right triangle, and she says we can use Pythagorean theorem, which is a squared plus b squared equals c squared. And the a and b value are my legs. So what's a leg? What number is a leg? 10. Okay, 25 is not a leg. It is the hypotenuse, which is your c value. Okay? So then you simplify. You get 10 squared, which is 100. And I'm pretty sure that's 625, but let me check myself. 25 times 25. Pretty great. What'd you get? So you do get 625. And then you subtract 100 from both sides. And I get 525. And then I want to take the square root, because in order to get rid of a square, you take the square root of that number. And it gives me a decimal. And unless it tells me to round it, I don't want to round it. I want to simplify it. The square root of 525. What are factors of 525? Anytime it ends with 0 or 5, you know that it has a factor of 5 in it, right? So 525, I can take out a 5, and I'm left with 105. Well, again, it's left with a 5 on it, so I can take out another 5. By dividing by 5, I get 21 and 5. And factors of 21 are 3 and 7, right? So I'm at the end of my little tree. I've got 2 5s that I can group together, and I got 2 numbers that are by themselves. All right, so what's 5 times 5? So I've got the square root of 25 times the square root of what's left over, not grouped, 3 times 7. And 3 times 7 is, so I got the square root of 21, and what's the square root of 25? So there you go. Okay, so a little lost. When you simplify a square root, you're looking for perfect squares. And a lot of us don't recognize those, so I do a little factor tree. Factors of 525, I can divide by 5. If I divide by 5, I get 105. And then 105 has a 5 in the end, so I know I can divide by 5 again. So divided by 5, and I get 21. And factors of 21, I know that 3 times 7 gives me 21. Those are my factors. 3's prime, 7's prime, and the 5's are prime. So I know I'm at the end of my factor tree. When you simplify square roots, you want to group 2 numbers that are the same together. And I have a 5 on the end and another 5 on the end. Even though they're not close to each other, they're still factors of 525. I multiply them together, and I get 25. Anything left over has to be multiplied together and put underneath the radical. That will not simplify anymore, the ones that don't have matches. But when I take the square root of 25, that's a perfect square. That gives me 5. Anything left over gets multiplied together and put underneath the radical. When you have physics, you'll have to simplify square roots, and they're going to make you do it this way. All right, so we're on definitions. You have tons and tons and tons of definitions. The median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. In other words, it's going to look something like this. I have a triangle, and the median, okay, is at the midpoint. It's a segment whose endpoints are on the vertex of the triangle and the midpoint of the opposite side. So it does something like this. Okay, that's a median. Midpoint of the other side, and it goes to one of the vertex. Now, in a triangle, you'd have 3 medians, right? In a triangle, you'd have 3 medians. It's not the perpendicular bisector. Okay, it doesn't have to be. but it is in the middle. Okay, the centroid is this, the point of concurrency where all the medians intersect of a triangle. Lots of common, similar definitions, just slightly different. You got to be careful on that definition test. And the altitude of a triangle. Altitude creates a 90-degree angle. It's a perpendicular segment from a vertex to the opposite side. Again, it does not have to be the perpendicular bisector. It just has to be from the vertex point straight down and make it a 90-degree angle. That's your height. Anytime we talk about altitude in the future, that will be the height of the figure. Another definition is called the orthocenter. And again, it's a point of concurrency where your altitudes intersect. So orthocenter is where your altitudes intersect. Again, the definitions are very, very similar. A lot of them are points of concurrency, but it's with different segments, whether they're altitudes, whether they're perpendicular bisectors. Okay, there's a theorem. Concurrency of the median of a triangle. The median of a triangle intersects at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. Okay, careful what it means. If P is a centroid of ABC, okay, if that's the case, so P is a centroid. We're dealing with the median. Remember, the median goes from the vertex to the edge, right? This segment right here is 2/3 of the whole segment. This is 1/3. Okay. Okay, so whatever the length is. So for example,
Well, how do you get 2/3 to 1/3?
from this theorem, this median.
All right, so know the middle, so
Okay, so if I knew the segment PE, okay, so I said PE is, I don't know, let's say 5. Well, then you can figure out what PC is, right? Because 5 is 1/3 of the whole thing, right? 5 is 1/3 of the whole thing. 2/3, what do you think that would be? PC is 2/3 of the whole thing. It'd be 10. And the whole thing would be what? 15. So for example, let's see, AP, that distance is 2/3 of the whole thing. Okay? AP is 2/3 of the whole thing. So from A to P, right, it's 2/3 of everything. So if you know the whole distance, you can just multiply by 2/3. Okay? That might be easy too. We'll do some examples of those in just a minute. All right, the last theorem, the concurrency of altitudes of a triangle, says this. The lines containing the altitudes of the triangle are congruent. Okay? So the lines containing the altitudes of a triangle are congruent. And if AE, BF, and the segment D or CD are altitudes of the triangle, then the lines AE, BF, and CD intersect at point H. All right, so here we go. R is a centroid. Okay, it's a centroid, so that's kind of key to know. STU and SR of the triangle STU, and SR is 16. So this length right here is 16. Remember, that's 2/3 of the whole thing. Find SV and find RV. All right, so we know that R is the centroid, and SR is 2/3, right, of the whole thing. So 2/3 of SV. Everybody agree with that? Okay, so we just substitute it in. 16 equals 2/3 SV. We don't know what that is yet. If that was, SV was X, how would you solve? Do you remember how do you get, instead of dividing by a fraction, you really do what? Multiply by the reciprocal. Remember that? You could divide by 2/3, but you've got to use parentheses if you use it in your calculator. The 3's cancel, the 2's cancel. If you multiply to one side, you got to multiply to the other. All right. You can do 16 times 3 divided by 2, which is 24, equals SV. All right, now I know that SV is 24, right? Everybody agree? Substitute in. So the whole thing is 24. If this whole thing is 24, and this little piece is 16, how do I find RV? Right, you just subtract it. 24 minus 16 equals your RV. So 8 equals RV. 8 units, whatever it is. Okay, next slide. Find the coordinates of the centroid, C. Okay, now go back to the beginning. Centroid is the point of concurrencies of the medians of the triangle. So we're looking for the midpoints of each side, finding where they are, going for that midpoint to the vertex, and where they meet, where all of them meet together. That is your centroid. All right, so what I did is I found the midpoint. Now, easy enough, I can find the midpoint from 1, 1 to 9, 1. Everybody can see which one it is? Since it's a straight line, I can just count over to where the middle is. Okay, that's one of my midpoints. And it's already got it for me. That's the altitude also for this one. Okay, got one there. But now I need to find the midpoints here and here. All right, so you want to check it out. It looks like maybe G and H might be the midpoint, but you need to check it out. So we can find the midpoint of EJ, okay, and that's going to be the midpoints of all these. All right, you check it out here and here. So let's do it. We've got the midpoint, and I'm using the points from E, or D and F, which we said was 5, 1, right? And you can see it there. What else are we looking at? So the coordinates of J we just said was 5, 1. Okay. And we need to find the middle point between G and F and D and H. But first, what's the distance from here to here? 1, 2, 3, 4, 5, 6, right? So EJ has 6 units. Okay. Good. All right, and we can find the midpoint from B to E. and that is at 1, 1 and 5, 7. Does anybody remember the midpoint formula? No. So the midpoint formula says this. Equals your x values added together, so 1 plus 5 divided by 2, and then your y values added together. So you get 6 over 2, which is 3. And here you get 8 over 2, which is 4. So 3, 4. Let's check ourselves. 1, 2, 3. 1, 2, 3. Excuse me. 1, 2, 3. 1, 2, 3, 4. Good. So G is the midpoint of DE, and H is the midpoint of EF. You need to check that. That's one thing it shows you on my graph because I wrote it in there, but you need to make sure that you check that when you do your homework, that they are the midpoint. All right, when they intersect, the point where these intersect, if you drew a straight line, you're going to notice it's at 1, 2, 3, 4, 5, and up 1, 2, 3. So the centroid is located at 5, 3. But you do need to check yourself, even though I already had it written up there. The graphs that are on your homework will not have the midpoints for you. Last one. All right, is the centroid, or excuse me, is the orthocenter of triangle ABC located inside, outside, or on the triangle? Now, the orthocenter, does anybody know what that is? It's the point of concurrency where your altitudes intersect. Now, what's an altitude? Anybody remember? What's an altitude? Starts at the vertex and it goes where? Not necessarily up. A lot of times it is the height. It goes to the edge of your picture, creating a 90-degree angle, right? So, like this one here, from my vertex straight down, making a 90-degree angle. Okay. And then this one, straight down, make it a 90-degree angle. And then this one, straight down, make it a 90-degree angle. Would it be on the inside or the outside or on the triangle? The point where they intersect. Inside. Okay, and you're going to figure out why. Okay, on today's homework. Why that picture occurs. Why is it on the inside? You'll have to describe what that triangle looks like. All right? This one. Use the diagram at the right to locate the orthocenter D. Okay, the orthocenter is located blank on triangle ABC. Is it on, in, where? Let's see. So, 90-degree angle. 90-degree angle. And this one? 90-degree angle. So it's on the inside. Okay, again, depending on what kind of triangle you draw, depends on where it lands. And again, the homework, when you manipulate your pictures, you're going to see where it is. All right, to find the orthocenter. Find the orthocenter. From each angle, you draw a line to the opposite side, making a 90-degree angle with that side. And where all lines intersect is called the orthocenter. That's the point of concurrency of the altitudes. Now, these are some extra examples, but I wanted to make sure you understood it before you had your homework. T is the centroid of the triangle, QRS, and TU is 7. All right, so centroid, remember, there's a special little thing you need to remember about centroid. You can find the links by, they're done in thirds or 2/3, right? So TU is 7. Find the whole length and find what's left over, QT. What did I say about centroids? One piece is 2/3, one piece is 1/3, right? And remember, the smaller piece is 1/3 of the whole piece. So we know TU, right? What's TU? 7. So 7 equals 1/3 of QU. Well, how do you get rid of 1/3? You can divide by 1/3, and if you do that, you have to use parentheses around it, or you can multiply by 3, the reciprocal. So if I do it to one side, I've got to do it to the other. So 21 equals QU. That's that whole length right here. That whole length right there is 21 units. So what's QT? Okay, you can either take 7 and multiply by 2, or you can do 21 minus 7. Right. Either way is fine. 14 units. My question is the orthocenter of isosceles and isosceles? What's isosceles? At least 2 sides are equal. Very good. Always. So is the orthocenter of the isosceles triangle always located inside the triangle? Yes or no?
Yes.
Everybody agree? Yes? Okay, it's not. The key word is always, and it's not. And here's the reason, and you're going to notice this. The acute is always going to be inside. A right is going to be on. All right, and an isosceles can be a right triangle, a right isosceles triangle. And obtuse is going to be out of it. It's kind of nice to know that you will be able to figure that out.